Fragility analysis of concrete elevated water tank under seismic load. The objective of this present research, the analysis of fire function related to the overall stability of an elevated water tank under the seismic hazard. Development of probabilistic approach based on Monte Carlo simulation to analyze the reliability of elevated water tanks submitted to hazard seismic loading. This reliability approach takes into account mainly two parameters. Firstly, the hydraulic charge in the tank container. Secondly, the hazard seismic loading. Development of fragility curves depending on seismic zone and soil type using the probabilistic approach. The stability of the tank under seismic action should be verified with the stability to overturning, stability to sliding. Serviceability limit state of tensile stress in steel reinforcement, serviceability limit state of compression stress in concrete and sloshing effect. To illustrate the reliability analysis, this application considers a reinforcement concrete water tank with a capacity of 1,000 cubic meter elevated pedestal. In the table represent the geometrical characteristic of the elevated tank. In this study, two parameters related to the seismic action and the hydraulic loading are considered. For the seismic action, the Gamble probability distribution is adopted. For the results, this figure shows the evaluation of the fire probability for the following mode: overturning, compression stress, and sloshing, as function to the different seismic zones and the height in the water height in the tank considered 15% of its maximum capacity and 100% of its maximum capacity. In these figures, show the fire probability as a function of the seat effects and the water height in the tank, considered 15% of its maximum capacity and 100% of its maximum capacity. The 2D and 3D fragility curves show of the probability of fire with respect to the soil type and seismic zone. In these curves, the influences of the hydraulic charge and seismic zone on the soil type is represented. In conclusion, through this study, we were able to demonstrate that the most prejudicial fire mode of evaluated tank is the compression of the supporting system when the container is filled to less than 50% of its maximum capacity. The most prejudicial fire mode is the sloshing mode when the water height in the container is near of the overflow level. And we can conclude that the Algerian seismic code must more consider this problem of sloshing by proposing a relation that allows estimating a practical height of freeboard. The analyzed tank in this study has been the subject of a deterministic analysis. All safety factors were found higher than those required by the dimensioning codes, where our analysis has shown the low level of its reliability. We can conclude that, faced to the complexity of the hydrodynamic behavior of evaluated tanks, the consideration in engineering calculation during the design stage in the engineering offices of the uncertainties by reliability analysis is essential today to better understand the fire risk. Thank you.